Today we're going to be reviewing linear equations and how to find the equations of lines in the plane. So let's start by remembering how to solve linear equations. If I have something like 4 times x minus 2 equals 5x, hopefully remember that our first step should be to distribute 4 to both items on the left. So we get 4x minus 8, that needs to equal our 5x. Next, I need all my x's on one side and my non-x's on another. So I'm going to choose to move the 4x over to the right-hand side, which will give me that negative 8 is equal to x. Hopefully we should remember that from algebra. So let's go ahead and take a look at another. If I have 1/3 x plus 1/4 equals 1, there's actually a few different ways I can go about solving this. The most common is probably going to be for you guys to subtract 1/4 from both sides. So now I'm going to get that 1/3 x, and if I have 1 and I take away a fourth, that leaves me with 3/4. If we can't remember that, you can make 1 4 over 4, and 4 minus 1 gives me the 3. Then I'm going to multiply both sides by 3 to get rid of the 3 on the denominator on the left, so x is going to be 9 over 4. Okay, that way wasn't too bad. 1 minus a fourth, most of us know is 3/4, but sometimes our fractions are really nasty looking. So personally, I choose to get rid of my fractions sometimes. So what I could have done is taken my 1/3 x plus my fourth equals 1, and I can choose to multiply everybody by 12. That'll get rid of the 3 and the 4. So when I go ahead and distribute my 12, 1/3 x times 12 is going to give me 4x. Then 12 times a fourth is going to give me 3, and then 12 times 1 is going to give me 12. So now I have 4x plus 3 equals 12. I subtract 3 from both sides. I'm going to get that 4x is equal to 9. Divide both sides by 4, and look at that, I got the exact same answer as 9/4. So that's going to give me my answer, and I'm all set. Remember that you can always give answers as decimals or fractions. It won't ever matter to me. Just make sure that your fractions are reduced if they can be. We're going to go ahead and skip this problem for right now. We're going to do it in class together because I want to walk you through how to use your calculator, so we'll take a look at that one later. So let's go ahead and skip to inequalities. So if I want to solve an inequality and then draw my solution on a number line, it's going to work exactly like our equations did. The only difference is if we multiply or divide by a negative, and hopefully we remember that if we multiply or divide by a negative, my inequality is going to flip directions. So for my first problem here, I'm just going to subtract 5 from both sides, which is going to give me x has to be less than negative 8. That's perfect. I didn't multiply or divide by a negative, so that's completely done. And now I just need to graph my solution. So I draw my number line, I draw negative 8. I'm going to put an open circle or parenthesis at negative 8, and my arrow is going to point to the left. And that's my answer. On my one over here where I have a double inequality, going to work almost the exact same way, except for this time I'm just going to subtract 5 from everybody to start. So negative 7 minus 5 gives me negative 12. It's going to be less than negative x, which is going to be less than 7 minus 5 is 6. Then I need to divide everybody by negative 1 to get rid of the negative in front of x. So I'm going to have 12. I divided by a negative, so that inequality flips from a less than to a greater than. 6 divided by negative 1 gives me negative 6, and that inequality is going to flip from a less than to a greater than. If I want to, that's the same thing as this, saying that 12 has to be bigger than x, which has to be bigger than negative 6, is the same thing as saying negative 6 has to be less than x, which has to be less than 12. Then I'm going to go ahead and graph my number line, put 0 in, I'm going to put negative 6 in, I'm going to put 12 in, I'm going to have an open circle at negative 6 and an open circle at 12, and I'm going to draw my line in the middle to connect them. Hopefully we should remember how to solve inequalities that are linear like this. And again, either one of these two, the 12 greater than or the negative 6 less than, is a perfectly acceptable answer. Next up, we're going to go ahead and remind ourselves about lines and the way they work. So the first thing I want to remember is how to find the slope of a line. And we know that slope is change in y over change in x. That's what this little triangle means. It means change. So change in y over change in x, which can be found by subtracting my y's and then dividing it by what I get when I subtract my x's. So we're going to start just by finding the slope between some points real quick. So if I want the slope between negative 3, 5 and 4, 9, I'm just going to go ahead and take my two y values, which are 5 and 9, and I'm going to subtract them. And I'm going to put it over what I get when I subtract my x's, which are -3 and 4. So that's going to give me -4 over -7, or 4/7. Hopefully we remember that it doesn't really matter which one we pick first. If I'd chosen the 9 first instead of the 5, I would have ended up with the exact same answer of 4/7. Slope we don't want to write as decimals. We like to write it as fractions as much as possible, so let's go ahead and leave it that way. For letter B here, go ahead and hit pause and then find the slope on your own, please. We should have gotten a slope of 8 for letter B. I took my -5 and I subtracted my 3 to get the -8 on top. Then I did -2 minus a -1, so it became a +1. That gave me -1 on bottom. The negatives canceled and I just got 8. The only other way they can really switch that up is by giving me a point and telling me what the slope is and asking me to find an x or y coordinate. It's the exact same stuff that we were doing before. The only difference is I'm going to know what my slope should be. So in this case, if I go to find my slope, I'm going to do 9 minus 3 over 5 minus x, and this time it has to make 2. I know that 9 minus 3 is 6. I don't like the 5 minus x being in the bottom, so I'm going to do 2 steps in algebra in one by just taking these two things, the denominator and everything on the other side, and making them trade places. So now 6 over 2 is equal to 5 minus x. That gives me 3 is equal to 5 minus x. So I'm going to subtract 5 from both sides. So -2 is equal to -x, so that would mean that x has to be 2. Go ahead and hit pause and then do letter B on your own, and we'll check answers in a second. We should have gotten y equals 16 for an answer. I chose to do y minus my -5 and then 4 minus a -3 for my slope. I only picked it that way because it made the negatives go away. It doesn't matter if you did it the other way. Still would have ended up with my answer. 4 plus 3 in the bottom gave me 7. So then I multiplied both sides by 7 to make that go away. So y plus 5 equaled 21. Subtract 5 from both sides and we should get that y is 16. Okay, so next up we're going to talk about our equations of a line. There are all sorts of different forms. General form is going to be ax plus by plus c equals 0. A and b cannot both be 0, and we can't have any fractions in our answers. So we'll multiply to make those go away if need to be. Other than your homework, a test or quiz is not going to specify which form to write it in. If it doesn't specify the form, you may choose whatever form you want to write it in. Slope-intercept should be y equals mx plus b. That should be really familiar from Algebra 1. Point-slope form is my favorite form. If you take AP Calc next year, it is the most common form that we're going to use, and it's going to be y minus a y coordinate is equal to the slope times x minus the x coordinate of a given point. If you have a vertical line, it's going to be x equals whatever the x coordinate is, and if you have a horizontal line, it's always going to be y equals whatever the y coordinate is. So let's go ahead and find some equations of lines. So our directions specifically tell me to find my equation in point-slope form. So to remind ourselves, point-slope form is y minus y1 equals my slope times x minus x1. So for letter A here, I know my slope and I know a point. That's going to give me x1 and y1. So I'm going to have y minus 4, because that's my y coordinate, equals my slope of 2 times x minus the x coordinate, which is 1. And that's point-slope form, so I'm all done. Hit pause and go ahead and do letter B on. We should have ended up with y plus 4 equals -2 times the quantity of x minus 5. It's going to be y minus my y coordinate of -4, so minus the negative became a plus. Then it's going to equal -2 times x minus 5. Since this one asked for point slope, I'm done there, but if it had asked me for the problem in slope-intercept form, I could have just distributed the -2 and moved the 4 over and I would have been okay. So our next problem wants me to find it in general form. So I have 2 points and I want my general form equation. I'm going to go ahead and start off by finding my point slope, and then I'm going to remember that general looks like ax plus by plus c equals 0, and then I'm just going to manipulate my equation to make it look like that. So step 1, I need to find my slope. 6 minus a -2 over 1 minus a -7. It's going to give me 8 over 8, which gives me a slope of 1. Then I'm going to pick one of my 2 points. It doesn't matter which one. I'm going to pick 1, 6 because it has smaller numbers. So I'm going to have y minus 6 equals a slope of 1 times x minus 1. When I go ahead and distribute my 1, it's going to give me y minus 6 equals x minus 1. Then for it to be in general form, I need it to say equals 0. So I'm going to subtract x and add 1. Subtract x and add 1. It's going to give me negative x plus y minus 5. And that's going to equal 0. Remember that for general form, I'm not allowed to have any fractions, and x and y both can't have coefficients that are 0. I don't have 0 coefficients for x and y, and negative 1, 1, and negative 5 are not fractions, so I've already met all the criteria for being a general form equation. So I'm done, box it up, and that's my answer. If we want to go ahead and find our general form for letter B here, again, we're going to start by finding our slope. So it's going to be negative 3 minus a negative 3 all over 5 minus 1, which is going to give me 0 over 4, which is 0. Okay, for those of us that remember, if our slope is 0, it means we're a special type of line. If you remember what that is, you can hightail it to your answer. Otherwise, we'll go through it and then we'll remind ourselves in a second. Okay, so let's go through it the long way. If I use a slope of 0 and I pick one of the points, like 1, negative 3, I'm going to have y minus a negative 3 is equal to slope of 0 times x minus 1, which is going to give me y plus 3 is equal to 0, because that's what happens when I do 0 times x minus 1. And that is going to be my general form because it already says equals 0, and both x and y don't have coordinates of 0, or coefficients of zeros, and there are no fractions. For those of us that remember what it means, if you have 0 slope, we are a horizontal line. And if I have a horizontal line, I know that my equation is going to be y equals whatever the y coordinate is. So in this case, it happens to be negative 3. And since they told me it needed to be in general form, I know that needs to say equals 0. So I would just add 3 to the other side to give me y plus 3 equals 0. Again, it doesn't matter which method you use as long as you can get yourself your answer. Okay, so for these ones, we're going to remind ourselves what it means to be parallel or perpendicular to given lines. Remember that parallel lines have equal slopes, while perpendicular lines have negative reciprocals for slopes. So for my first one here, they're going to give me an equation that I want to be parallel and then perpendicular to, and a point that I'm going to use. Okay, notice that my directions did not tell me a specific form to write it in, so I can choose. It doesn't matter, we're going to use it. So for part A here, if I want to be parallel, I know that this line has a slope of 5, because that's the number in front of x. So for A, I'm going to use a slope of 5, and I'm going to use the point negative 7, negative 2, which is going to make my equation. I'm going to use point slope, because again, it's a little bit easier. So it's y minus the y coordinate of negative 2, so that's going to become plus 2, equals my slope of 5 times x minus the x coordinate, which is a negative 7, so it's going to become plus 7. I'm going to box it up and call that my answer since it didn't tell me I had to write it in anything else. So made it easier to do point slope. For letter B, I'm going to use a slope of negative 1/5 because that's the negative reciprocal to 5, and I'm still going to be using the point negative 7, negative 2. So my equation's now going to be y minus the negative 2, because that's my y coordinate, is negative 1/5 times x minus my x coordinate of negative 7. And it'll be almost the exact same line. The only difference is instead of 5, I get negative 1/5. Hit pause and do number 2 on your own, please. When I go ahead and do number 2 here for part A, I need to find my slope first. So the first thing I need to do is take my 4/5, or my 4x plus 5y equals 16, and write it into slope-intercept form so I can steal the slope. So I subtracted the 4x over, and then I divided everybody by 5, which gave me a slope of negative 4/5. So for part A, I'm going to use negative 4/5 for my slope, and my point is negative 3/4. So I'm going to have y minus 4, because that's my y coordinate, is going to be equal to negative 4/5, because that's my slope, times x minus the negative 3, because that's my x coordinate. And I'm done with part A. For part B, it's the exact same equation. The only difference is instead of using a slope of negative 4/5, I'm going to use a slope of positive 5/4, because that's my negative reciprocal. In class on tomorrow, you guys are going to be working on page 28 and 40, 1 through 23 odd, 35 to 41 odd, and 1 through 25 odd. If you have any questions, make sure you go ahead and ask me, and we will be doing the one where we solve graphically on our calculator, just so that way we can start getting used to how we use our calculators. Hope you guys had a great weekend. Bye.